Newton's second law, this is also called the law of acceleration. Now, your formula here would be F equals ma, or F equals mass multiplied by acceleration, where of course F there would be the force, m is the mass, and a is your acceleration. So this states that an object's acceleration is directly proportional to the force applied on it. Okay, so again, an object's acceleration is directly proportional to the force applied on it. Now say you have a basketball here. Okay, if you try to hit that basketball with a force of 1 Newton and it moves maybe a distance of 5 meters, okay, so your second law here states that the force that you have applied on an object, that would be directly proportional to its acceleration. So again, in the example that I have given you, you have a ball, a basketball, and you have applied a force of 1 Newton. And so it has reached, or it has traveled a distance of 5 meters. What do you think would happen if, say, you double the force, the amount of force that you apply in it? You can say the acceleration would also be doubled, okay? Because of course, acceleration is directly proportional to the force applied on it. Now, the second part of your law here states that it is inversely proportional to its mass. That means acceleration would be inversely proportional to its mass. Now say you have another ball here. This time it's a golf ball. Okay, so you have two types of ball. Of course, we know that your golf ball is going to be lighter than your basketball. What do you think would happen if, say, you apply an equal amount of force on them?
The golf ball would have a higher acceleration than the basketball would.
Why is that so?
Because the golf ball has a smaller mass than the basketball does.
Okay, that's correct. Okay, so both of you are right in saying that the golf ball, of course, is going to have a higher acceleration because, of course, this is lighter. Okay, it has a lighter mass. And so it says here, your acceleration is inversely proportional to its mass. So that means the bigger the mass or the heavier the object is, the less acceleration it would have. These are the different formulas that we are going to be using in today's activities. All right, now let's take a look at your sample problem here. Sample problem number 1. What is the force required to move a 5,000 kilogram car with an acceleration of 4 meters per second squared? Okay, we're looking for the force. And so we know that the formula that we should use is F equals m times a. Okay, so again, I repeat, force equals mass times acceleration, which is actually very easy. Okay, so we say force equals mass times acceleration. So we simply multiply the two quantities that we have here. Our mass, of course, is 5,000 kilograms. Then we simply multiply that by the acceleration of 4 meters per second squared. Okay, so again, that's 5,000 kilograms times 4 meters per second squared. Our force needed would be 20,000 newtons, or again, 20,000 newtons would just be equal to 20,000 kilogram meter per second squared. Okay, so again, final answer is 20,000 newtons or 20,000 kilogram meter per second squared. All right, now sample problem number 2 here. The question is, what is the mass of a car pushed with 19,000 newtons that accelerates at 10 meters per second squared? So again, we're looking for mass, the mass of a car. This is being pushed with a force of 19,000 newtons, and it accelerates at 10 meters per second squared. So that's the mass. That means the formula that we are going to use would be force divided by acceleration. Okay, so mass equals force divided by acceleration. Now, our force is given as 19,000 newtons. And of course, acceleration is 10 meters per second squared. So this is going to be our equation. 19,000 newtons divided by 10 meters per second squared. That's just 19,000 divided by 10. So we simply cancel one of the zeros here. Okay, so cross out the 0 and the other 0 here in your denominator. That means we are left with 1,900 kg or 1,900 kilograms. Okay, so that would be the answer for sample problem number 2. The mass is 1,900 or 1,900 kilograms.